Hello everyone, welcome to even digital class. So in today's class of computer organization, we will discuss out of order execution. So this sounds something different because we know that when we are executing some instruction, that means we are executing in an order. That means there is specific manner by using which we are executing the instructions, or you can say the processor executes the instructions, or you can say that instructions are entered into the processor in a sequence way. But when it comes to the execution of the instructions, that means when the processor executes that instruction which comes sequentially, and that execution is out of order. That means the execution is not in a proper sequence. Okay? And what is the condition actually where we will get the out of order execution? Let us take an example that the operand or you can say the destination location of one instruction is treated as the source operand of another instruction, and let the instruction is our I1 and there is one operand which is used as the destination and that is used as a source operand in the next instruction, that is our I2. That means the execution of I2 completely depends on the execution of I1. So in that type of case, the execution may not be in a proper sequence. Okay? So this type of situation is called as out of order execution. So we will discuss it in the today class about this in a detailed manner. So we will discuss here that about the hazards, then what do you mean by the exceptions, and imprecise the exceptions, then precise the expressions. So we will discuss about all of these things in this. So first we will discuss about what do you mean by delayed write. Okay, that means we know as long as the dependency is handled correctly, there is no reason to delay the execution. Okay, that means if the processor resolves the problem of occurrence of the hazards, then there is no delay. So next concept is comes that exceptions may be caused by a boss error. Here I have already discussed that about the hazards and the exceptions. So what do you mean by exceptions? So exceptions arises when a new complication is considered and that is possibility of an instruction. Okay, so that is called as an exceptions, and the exceptions may be caused by any type of boss errors, and when the boss error will occur when we are fetching the operands. That means when we are fetching the operands, let the boss is busy in performing some other operations or it transfers some other data or the information. Then such as an attempt to, we can say the example is our 1 is our divided by 0. So divided by 0 is one type of exceptions. Then the result of another instruction will be hampered. So here you can see that in this diagram I have already discussed. This diagram is also in the superscalar operation and it is also in this out of order execution concept. So I1 F added, that means this instruction is performed the arithmetic operation of floating point numbers, and here this instruction performs the integer type of operations, and this is for the floating point operations and this is for integral type of operations, and the result of I2 are written back into the register file in cycle 4, because the execution of this instruction, if we are executing this, that means we have already discussed that when we are executing a floating point instruction, that means it needs multiple clock cycles to complete its execution. But in case of integer, one cycle is enough to complete the execution. So the result of I2 as it is written in the register file in the clock cycle 4. So if the I1 causes an exception, then the program execution is called as an inconsistent state. So the program counter points to the instruction in which exception occurs, and then the one or more succeeding instructions which have been executed to completion, and if such a situation is permitted, the processor is called as imprecise exceptions, which I have written here. So, what do you mean by imprecise exceptions? That means if the exception occurs due to any type of instructions, and then at that point of time the program execution is called as in a inconsistent state, that means it is not in the valid state. So, then the program counter, what it will points? It will points to the instruction which occurs the execution, or due to the presence of the instruction the exception occurs. So, the program counter will points to that, and the instructions which are succeeding to that executed to be completion. Then this cases is called as our imprecise exceptions. Then a consistent state, when exception occurs, the results of the exception of instructions must be written into the destination location strictly in the program order. So, in this diagram you can see that we must delay the step W2 in this diagram until the written up result of instruction I2, or you can say the delay of writing the instruction, the result into the register file which is occurred in the clock cycle 6. What is the reason? When we are delaying this, the integer execution unit must return the result of instruction I2. As this is delayed for some period of time, then the processor cannot accept the instruction I4 until clock cycle 6. As we have discussed, or you can say in the superscalar operation, what it says that we are using multiple execution units, and multiple execution means the execution unit, one is for executing floating type of operations, one is for integer type of operations. So, in this type of diagram, to implement it by using superscalar operations, we use only 2 execution units. So, the execution unit which is used to execute the instructions of type integral. So, for that reason, as the execution unit is busy in executing this I2, then it cannot perform the execution of I4. Okay. So, we delayed for some period of time so that the processor cannot accept the instruction I4 until the clock cycle 6. So, if an exception occurs during an instruction, all the subsequent instructions that may have been partially executed are discarded. Okay. In other words, we can say that if an exception occurs during the execution of an instruction, then all subsequent instructions that may be partially executed, that means which is executed but not written, or which execution process is in undergoing. So, that type of execution will be discarded. So, that type of exception is called as precise exceptions. So, what do you mean by precise exception? Precise exception means if an exception occurs, here I have written that precise exception. So, it means that if the exception occurs, then the instructions which are partially executed, that execution has to be discarded. So, it is easier to provide precise exceptions in the case of external inputs. When an external input is received, the dispatch unit stops reading the new instructions from the instruction queue, and the instructions remaining in the queue are discarded. Okay? Because the fetching unit fetches multiple instructions and it stores that in an instruction queue, and from that instruction queue the dispatch unit collects the instruction and then it will gives that to the execution unit. Okay? So, when an exception occurs, the dispatch unit will not receive or you will not read any new instructions from the instruction queue, or you can say whatever the instructions remain in that queue, it will be discarded, and all the instruction whose execution is pending to continue to completion at this point, the processor as in the consistent state. Okay. So, in this diagram, that means if an exception occurs, let in the case of this I2, then all the instructions which are remained, or you can say this instruction I3 and I4, this execution will be discarded for some period of time. Okay. Next concept is our execution completion. Okay. So, it is desirable to use out of order execution, so that an execution unit is free to execute other instructions as soon as possible. So, sometimes this is benefited if the out of order execution occurs, because if we will perform the out of order execution, then the execution unit is free, or it is idle for some period of time, and in that idle period it can execute other instructions as soon as possible. So, at the same time, instructions must be completed in program order to allow precise exceptions. Okay. So, what do you mean by precise exception? I have already discussed that if exception occurs, then we have to discard the in between execution processes, or the instructions which are undergoing its execution process. So, in that period of time, the instructions will be completed to allow the precise exceptions. So, the use of temporary registers were used here, and then there is a commitment unit. Okay. So, this is the case where we use the temporary registers. So, in the previous diagram which I have displayed, that if we will follow and if we will delay, then the pipeline will stall for 2 clock cycles. So, here the we use the concept of temporary registers. That means, if I2 depends on the result of I1, due to which the out of order execution occurs, so the execution of I2 will be delayed. So, these dependencies are handled correctly. Okay. And as long as the execution of the instruction will not be delayed. Okay. So, the reason is I have already discussed that exceptions are 2 causes: boss error and illegal operations. Okay. So, I have already discussed. So, let us see the concept. So, the exceptions are basically divided into 2 types. One is imprecise and another is precise. In the imprecise, the result of I2 written into register file during the clock cycle 4, I have already discussed in it in the example. So, if the I1 causes the exception, then the processor allows to complete the execution of the instruction I2. So, that is called as imprecise exception, and the precise means in imprecise exception, consistent state is not guaranteed. So, the exception occurs. So, for that reason, if exception occurred, then the instructions must be written into the program order in the consistent state, and the I2 must be allowed to written till clock cycle 6, and then the integer execution unit has to retain the result until clock cycle 6, and it cannot accept instruction I4 until clock cycle 6. So, we know that in the superscalar operation, let we are using 2 execution unit, one for integer execution, another one is for floating point. So, the integer execution unit has to wait until the result is written, okay, and the result will be written in clock cycle 6. So, in this method the output is partially executed, or you can say it will be discarded. Okay, so, that is the concept of precise exception. If an external interrupt is received, the dispatch unit stops reading new instructions from the instruction queue, and then the instructions remaining in the queue are discarded. Okay. When we will call out the execution completion, in precise exceptions, the results are temporarily stored into the temporary register, and later they are transferred to the permanent register in correct program order. So, in the precise exceptions, the result which are partially executed or discarded, they are temporarily stored into a temporary register, and later they are transferred to the process to be executed in the correct program order. So, the two write operations, that means TW and W are carried out. TW means the write operation is performed in the temporary register, and W means the write operation is performed in the memory part. Then here the step W are called as commitment step, which I have already told you in my previous slide, that there must be a commitment unit, okay, and the temporary register to permanent register. Okay. So, the commitment step is used, or it basically describes the transformation of the content from the temporary register to the permanent register, and the TW means written into the temporary register, W means transfers the content back to the permanent register. So, a register renaming means a temporary register assumes the role of the permanent register whose data it is holding and is given the same name. So, this is the concept of register renaming. Okay. So, register renaming is concept which describes that the temporary registers, because we are using the temporary registers, means we have to store the result temporarily in any type of location, because if we store the result of this execution unit in a temporary register, then this execution unit is free, and when it is free, then it can execute some other instructions. So, in this case, what will be considered? That the temporary register will be assumed that it will act as the permanent register. Okay. And register renaming means whatever the permanent register or whatever the name of the permanent register, the temporary register's name will be given same, because if we will change the name, then there may be some conflict arises. So, due to this reason, the register which will act as the temporary register, it will be assumed that it is one type of permanent register and the name will be same as the permanent register, and it will hold the data for some temporary period of time. So, after completion of the delay, then or the waiting stage, the result will be written into the permanent register, or you can say in the memory location permanently. Okay. So, this is the concept of register renaming. So, in today's class we have discussed about out of order execution. So, in that we have seen that if the exception occurs, then the execution of the instruction hampered, and there are different type of exceptions. One is our imprecise and another is precise. So, to overcome that, we use the concept of temporary registers, and in that temporary registers the result will be written into that first, and then it will be written into permanently to the register, and when it will occur, that means when we need the temporary register, when the dependency occur, that means the execution of one instruction depends on the execution of another instruction. So, in that case we will use the temporary register concept, and we will provide the name of the temporary register as the same name of the permanent register. So, if you have any doubt regarding this concept, you can mention it in the comment box. Till then, keep watching. Thank you.